Hi, welcome you all for the second session, which is all about process management. What do you mean by process? A process is a set of instruction to be executed which performs a particular action that has been considered in a given program. So, if I take an example, let us say if you have downloaded any web browser, let's say Google Chrome or any web browser. So, once you have installed the executable file, so if you click on a browser, if there is any delay with the network, you can be seeing something called as not responding. So that is also called as a set of instruction which is to be performed, which will certainly reply back with the certain actions whenever there's a delay in a network. In same way, you have many more process that is being added in a part of a program. So it can be with managing the history of the the website that has been browsed. It can be to consider something a bookmark to a particular website or a blog spot. So that I can say that a program which is an executable file either in terms of a software, or it can be in terms of a web browser, or it can be in terms of hardware interface. So program will have all the set of executable files. A certain task that has to be performed in that particular program is called as process. So, how the management of a process being done by the kernel, or I can say by operating system, is all about process management. So, let me go to the next slide, which I already emphasized on. That is, process is the execution of a program which will perform a particular action that has been specified in a given program. So, it can also be called to be as an execution unit, as every process which has been part of program is being called by the end user to perform particular task. So each child process will be having a control over in an operating system by a process operation, something called as a process control block, where each process which is being called by an user will have its own address space that has been allocated in a process control block. As the action that is being performed every seconds to whatever the request that has been raised by an end user, that's the reason the process is called as an active entity, and the program is called to be a passive entity. So that's what I was about to say. The program, it is, of course, it's all the set of executable instructions or a file that has been there in a given folder. So now, many of them would have a doubt of, like, whenever we save certain executable files or setup files, it can be anything which we call it as a program. So the question that arises is that, so where would the particular program or an executable file in an operating system be saved? It is certainly, it will be saved in the secondary memory. And all the major requirements of an operating system will always be stored as a backup or as a batch in a primary memory. So let's take an example. Suppose if we want to download any text editor, like let's say it can be a notepad which is already been there, or it can be a Microsoft Word. So if you try to right click your my computer, and if you go in depth with the properties, you can see that there's something called as manage or managing a memory. If you click on that managing of a memory, you can see there will be a segregation of a primary memory and a secondary memory. The primary memory will always be fixed with its memory space. So any end user using any laptop or a desktop will not be allowed to segregate the primary memory, which has already been allotted for the backup or the boot up of a system. Wherein for a secondary memory, all the executable files will be there as a part of a secondary memory. whatever the hard disks that you've been observed with the divisions of C drive, D drive, E drives, and so on. The divisions or the partitions can only be done in the secondary memory space, which is never possible to divide it in the primary memory. So the C drive that you are seeing is of course a part of a secondary memory, wherein all the backup executable files, which we call it as a program, we saved in that particular C drive. Okay, so if that is the case, if there is no there's no issues or a problem with what is process and program, let us see what is the key differences between process and program. So the key differences between the process and a program is of course it is a set of instruction that has been there in a given executable file. What is process? It is a part of a program which is to be performing a certain action. Okay, and what is the nature of the program and process? As said, program is passive in nature and process is active in nature. And then when it comes to the lifespan of these two entities, program is of course longer duration, because we will have the set of executable files that has already been there in a folder. But process, it is not a longer duration. We want that particular task or an action to be happen for that particular moment. Okay, it can be if we take Microsoft Word, it can be with increase of a font size, it can be with the changing of the font or whatever. This all comes under the category of the task or action, which we call it as a process in any text editor that we consider, which is of small duration. So process, when it comes with a lifespan, it is always limited in nature, and when it comes with a program, it is having a longer duration. And when it comes with the categorization of the required resources, certainly the program requires the large amount of memory to be saved. It can be in terms of executable file, it can be in terms of setup file, whatever it is, it requires a large amount of memory. When it comes to process, as we want that to happen, the action to be performed with certain minimum time limitations. So it may hold the amount of memory resources according to the requirement that is being come to the shell or to the CPU. It can be with regard to memory address, it can be with regard to the disk space allocation, or it can be with regard to the hardware interface or software interface that has been happening with regard to the central processing unit. So if everything is being known, now its main thing, how is the process being managed by the kernel, or I can say by the operating system. So as said, every process will be identified by its process ID, which we call it as PID. So every PID will be given its own address space in PCB. So now let us see the flow of the process, how it takes place. So this is the state diagram or the process state of any process that will take place in an operating system. So whenever there is a new process or a new process ID that is being created in order to perform a certain task, so basically there will be a request raised for ready from the user end, and then on basis of that, whether we will not know whether it is taking time or not, or whether it is certainly been performing within a given time limit. So after ready, we certainly will have something called as a waiting time. So after waiting time, we have to wait for the response for an execution. Once there is a proper response of execution from the kernel shell, then we tell it as terminated. Okay, there is also a case that if there is something, a delay that has been happening during the creation of a process, or it can be with the delay of resources, or it can be with delay of whatever the resource facilities that is to be facilitated for any process. If there is any delay that has been happened, what we will do, we will either suspend it, means we will either suspend that particular process that has been happened, or else we will certainly block that and again try to generate a new process for the required task to be done. So this is the process state. You can also see that if there is any issue or a problem that is happening during an execution, we will also be certainly be being blocked with the process or being suspended with the process. So this is the state diagram or the process state of any process that has been considered. So this is all about the process management. Thank you so much.